Welcome to classes on organic chemistry, and today's topic is general organic chemistry, and it is continuation of class number 13, and the topic was general organic chemistry isomerism. So if I recall, some of the points which I discussed in class number 13 is that I differentiate the isomerism into two parts. One is constitutional isomerism, other is configuration isomerism. Constitutional isomerism is structural and configuration isomerism is stereoisomers. That is, it is related to spatial arrangement of atom or group, and it is not related to spatial arrangement. And out of these two groups, two parts, I explained chain, constitutional isomerism, chain, position, ring chain, functional, up to this much. Today I have explain metamerism, tautomerism of constitutional isomerism and geometrical isomerism of configurational isomerism. So let me first start with metamerism. Metamerism is nothing but change in the nature of the alkyl group attached. So you see, I am taking in one example, change in nature of alkyl group attached. So I have taken one example, CH3O CH2, it is an ether, CH3O CH2 CH2 CH3. You see, O, it is the position O in second position. I have just taken the changed the position of alkyl. One alkyl has been taken towards left. So here CH3O, one CH3 group and 3 CH2 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 towards right. Just I have taken one CH2 towards left, CH3 CH2 or CH2 CH3. That is, change in nature of alkyl groups if occurs, that type of isomerism gives rise to metamerism, and metamerism is chiefly is shown in case of ethers. It is very important. In your book, only examples of ethers are given. Amines. These are the facts you should know, and also ketones. You will be surprised to know that ethers, thioethers, amines, ketones, all these will show metamers. But in your book, it is only given ethers. One example has been given. Now I will give you different types of metamerism which can be possible if there is O groups, if there is S, if there is CO, if there is N in the chain. So we can change the alkyl group keeping O towards right and left, changing alkyl group towards right and left of S, changing alkyl group towards right and left of CO, changing alkyl group towards right and left of this. So one of the example already I have shown you that ether, we have just changed the alkyl groups. So if there is change in alkyl group, when the functional groups O and CO or these are polyatoms. Am I right? So another examples, if you take an example, this is amine. Am I right? So So you see here I have taken an amine C3H7N, C5H7N. So I have just arranged, keeping N in the position, I have arranged it C3H7 or CH3CH2 CH2, NCH3CH3, and C2H5 C2H5 in both sides, and CH3. Just you see, we have changed the position of alkyl uh, to around nitrogen. These are metamers. So also if there is any sulfur, you can also do this. If there is any CO group, you can change the alkyl group towards right of left of CO group, and this will give rise to metamerism. So these are the very important part, metamers, very often in your state, and so also all India exam and also in the entrance needs questions very often asked for metamerism. So be keep your eyes on the metamerism, which is a constitutional isomerism. Now again very important one is tautomerism. So this is very important. Tautomers you will get in second year, in get in everywhere, and also very often question asks from tautomers in entrance exams, also in the class exam. So minutely follow what are tautomers. Tautomers actually not a substance readily exist into interconvertible substances leading to a dynamic equilibrium. You will get one substance and you get some instantly another substance, and both the substances are interconverting from each other, and they are in dynamic equilibrium, means the equilibrium exists between these two type of substances. They are called tautomers. Now how will get tautomers? So this is very important thing, you just follow. Say one compound I have taken CO, means ketonic compound, and COCH2R, this is alkyl, you write anything. So what's happened here and what is tautomers, I am telling you. Just you see, if you assume that hydrogen here, very interesting one, you follow the technique. So that hydrogen comes over here and bond inclined here. So what you get here is, so that one is keto, and that is double bond means in, and OH means all. So that is keto-enol isomerism. So this is keto-enol isomerism comes from tautomerism. It is the phenomenon is called tautomer. These are tautomers, and this phenomenon is called tautomerism because of the fact that here one hydrogen is now changes over, jumps or changes over to oxygen and bond inclined to that place. So you are getting OH, and that bond comes over here. You are going to double from ketone group to enol. So that is called keto-enol tautomerization. That is called keto-enol tautomerization. So these things also occurs I have taken an ester, and also here you will get tautomerization. How this happens? Again, let me write it. in this way. You take that hydrogen over there and move that double bond here. So what we get here is CH3 COH double bond CH C double O C2H5, and these are always in equilibrium. The one thing is interconverting our other, and it is generally 89.8%, and these forms occurs in 2%. So these forms are, both the forms are interconverting from each to another, and this is another example of, this is keto and this is enol, keto enol change. So this is keto enol tautomerization. I have given two examples. So now one new thing I am showing you. Desmotropism. It is a new thing and very often asked in exam, but you will tell, you may think that this term has not been appeared or find anywhere in the textbook, but this is exactly related to tautomerism, and it is another name given, a desmotropism. Here only hydrogen is involved. How? So this is again, desmotropism is another term used in case of tautomerism, which is caused due to wandering of hydrogen between two polyvalent atoms. So you see, HCl what's happened? There is wandering or oscillation of hydrogen from carbon to nitrogen. Carbon is polyvalent, nitrogen is polyvalent. Valence is 4, valence is 3. Am I right? So what I wrote here is caused due to wandering of hydrogen between two polyvalent atoms. And this is wandering of hydrogen or oscillation of hydrogen occurs between carbon and nitrogen. Here hydrogen was attached to carbon, now here hydrogen is attached to nitrogen. So oscillation of hydrogen occurs between between two polyvalent atoms from 1 to position. Since it occurs between two position of polyvalent atom, hydrogen oscillates, hence it is called diode system. It is a system where oscillation of hydrogen occurs between 1 to position of polyvalent atom, and that system is called diode system. Now, a bit earlier I have shown you, again it is tautomerism, example of tautomerism. Here what's happened? This changes to this and bond withdrawn here. What we get is now in the system what's happened? 1, 2, 3. The oscillation of hydrogen occurs 1 to 3. If oscillation of hydrogen occurs 1 to 3 position, then it is called triad system. I have introduced new terms, so you please learn. Sometimes this may ask, you can answer it very easily. So triad system is another form of tautomerism, tautomerization, where the shifting or oscillation of hydrogen or wandering of hydrogen occurs between two polyvalent atom which are in 1,3 position, and if such things occur, it is called triad system. Next, if you don't be confused, and if you see how we get this, I am showing you one mechanism. Say acid. If you use acid, what happen here? You see there is bond is withdrawn in this way, so it is negative, it is positive. First, that get attached with this one. So in this way, we get here positive sign. When this proton get attached with this one, so we get here positive. Bond is withdrawn, it becomes negative because it is electron withdrawing groups. More electronegative, bond is withdrawn towards it, so it becomes positive and it becomes negative. So in negative, the proton parts get attached and it becomes positive. So next step, what happens? Deprotonation occurs and bond is inclined. So you get so it is nothing but the one hydrogen has gone over there and bond is inclined here. It is tautomerization. So I have shown you the mechanism how it occurs. If you find it easy, you assume or you practice. Otherwise, you keep it in your mind what I told you earlier. So interesting fact about tautomerism is that tautomerism very often occurs when there is chances of alpha hydrogen. Once again, I am writing here. Say that hydrogen goes over there and bond withdraws. So we get the answer as this. So it is tautomerism. Am I right? Now what's happened here? You see, in the process, if this is a group with respect of this, it is alpha. So it is an essential criteria for tautomerization is that the compound or substance which will undergo tautomerization should or must contain alpha hydrogen, otherwise tautomerization is not possible. So in entrance exam, sometimes in your class, question of very often asked, which of the following compound will show tautomers and which one will not? So I have given you some of the compound: benzaldehyde, benzophenone, this is chloral. Am I right? So if these things are asked, and if in the option some things are given in, you are asked to find which one will show tautomers and which one is very important point where question very often asked. If you are asked whether they will show tautomerization or not, answer none of this will show tautomerization, because if you draw the configuration, you will find there is no alpha hydrogen. There is no alpha hydrogen here. If you draw this one, you will find no alpha hydrogen. Here there is no alpha hydrogen. Here there is no alpha hydrogen. So the main criteria for the for the tautomerization to occur is that the system must contain alpha hydrogen. So if in the options the compounds which will be supplied to you when you are asked whether this will show tautomerization or not, first of all you draw the structure and see whether there is any alpha hydrogen or not. If you find there is alpha hydrogen, yes, it will show tautomerization. If there is no alpha hydrogen, it will not show any tautomerization. So these compound will not show tautomerization. Tautomerization as they have no alpha hydrogen. Very simple, nothing tough. So important two things I have shown you. One metamerism and other is tautomerism, and these are the very active points over which very often question of occurs in exam, in your class exam, so also in the entrance exam. So minutely follow these two isomers of constitutional isomerism. Now the constitutional isomerism is over, which is nothing but structural isomerism. Now we will come to configuration isomerism, and configuration isomerism are nothing but stereoisomers. Stereoisomers means that they have the different arrangement in the space. The groups or atom attached to the carbon is arranged in the space, in three-dimensional space, and there is change in the arrangement of group of atom in the space, and due to which it will show stereoisomerism. So today I will discuss geometrical isomerism. Geometrical isomerism, conformational isomerism, rotation occurs through single bond. Rotation occurs through single bond, and there is change in spatial arrangement of carbon. Atom or group attached to the carbon, if you make rotation through single bond, that will be conformational isomerism. And optical isomerism is related to chirality, and geometrical isomerism is related to the double bond. If there is double bond in carbon-carbon or double bond carbon-nitrogen, I will show you the condition. Due to this restricted rotation about double bond causes geometrical isomerism. Why there is restricted rotation? Because when there is double bond, that double bond, one pi bond above and below of sigma bond. Am I right? So one is sigma bond, other is pi bond. Sigma bond is a single bond, and pi bonds in above and below the internuclear distances, they make some restriction in the moment of rotation of this sigma bond, and hence it is called restricted rotation. And due to this restricted rotation, there occurs geometrical isomerism. Am I right? So restricted rotation about double bond causes geometrical isomerism. Very often you are misled and you understand something in a very vague way. Very often you, maximum of the student knows that geometrical isomerism only occurs in case of carbon-carbon double bond, but it is not true. Geometrical isomerism may occur carbon-carbon double bond, may occur carbon nitrogen double bond, may occur also in single bond. I am showing you one example. This is cyclohexane. These two carbon are having single bond till there is geometrical isomerism, because the rotation occurs carbon double bond carbon, carbon single bond carbon, or in cyclic condition this carbon and this carbon are frozen. FROZD, frozen rotation, restricted rotation. Where there is chances of frozen rotation, restricted rotation, that may show geometrical isomerism. That frozen rotation in general is written in your textbook is that in double carbon-carbon double bond. Yes, it shows geometrical isomerism due to frozen rotation, but this also is shown by carbon double bond, and this also shown by carbon single bond. If this is a frozen, this is blocked, rotation is hampered, blocked. So three types of geometrical isomerism we can get due to rotation of carbon-carbon double bond, due to rotation of carbon-carbon single bond, due to frozen rotation in case of cyclic compound. So now let us explain elaborately how geometrical isomerism occurs. So first of all, we may take very simple example of geometrical isomerism. Very often, many of you know this is malic acid, this is fumaric acid. So what is the difference between these two is that in one time these COOH groups are in the same side, and other time COOH and COOH is in different position, one side and other side. And this type of the geometrical isomerism which occurs in carbon-carbon double bond, where same type of groups are on the same side of the double bond and same types of groups are on the opposite side of double bond, and first type is called cis and second type is called trans, or in general one is called malic acid and it is called fumaric acid. So the fact is that at least in carbon-carbon there must be two similar group, or in two carbon where there is double bond there should be one element or groups or atoms which be different, or other three may be same. That will show cis and trans isomerism. First type is cis and trans. So I have shown you cis and trans isomerism. Another is it is very common, many of you know, 1 2 3 4 butene, and where you see there are CH3 in one position, this is cis. If you change, if hydrogen is taken over and CH3 is taken below, then another will be, this will be cis, and if CH3 is here, H is here, this will be trans. So we have seen that the cis and trans isomerism very often occurs carbon-carbon double bonded compound, and same type of group are in this position. One in the same side of cis double bond compound, carbon-carbon double bond, and other structure is on different side is called trans. Same side is cis and different type is trans. Now one of the critical point is asked in the entrance exam, that say C double bond C I have shown you very interesting fact you minutely follow. Sometimes in the option you are given three or four type of the structure, CH3, Cl, bromine, iodine, like this, and you will be asked which one of the following structure will not show any geometrical isomerism. Mind that type of carbon double bond compound will never show geometrical isomerism, where these two groups are same and this is different. The group or atom attached to one carbon is same and other are different, it will not show any geometrical isomerism. Or this three atom or group are attached with the carbon double bond carbon are same, it will not show. Or the two are same and two others are also same, it will not show any geometrical isomerism. So mind that this type of arrangement of carbon-carbon double bond compound will not show geometrical isomerism, will not show geometrical isomerism. Mind that for entrance point of view, it is very, very important. So first type I have shown you cis-trans isomerism. So second type is syn and T. I have told you that only carbon-carbon double bond is not the only compound which will show a geometrical isomerism. That type of compound that is called oxime. Mind that C double bond NOH is called oxime. That if that is in this way, it is called oxime. Oxime, where C double bond NOH, that type of compound also shows geometrical isomerism, but these are not termed as cis and trans. These are called syn. This is syn. This is syn compound. Where you see, very interesting one in oxime. If OH and H are on the same side, then it is called syn. If H and OH in different type, in different side, that is called anti. Nothing more. This is syn and anti structure. OH and H on same side of carbon double bond N are syn, and H and OH are on the different side of carbon double bond N. It is called anti. The third one is again important. Again you will get C double bond C, but here you will find that you are not in a position to designate it by geometrical isomerism, cannot be represented by cis and trans representation, because if forehand of these two carbon is attached with four different atom or groups, different, all are different, there is no similarity, all are different, then that type of representation cannot be done, cannot be designated by cis and trans. What will you do in this type? If all the atom or group attached to carbon double bond carbon are different, then we'll represent this by E and Z notation. E means E means antigen, means across, and it is the same as trans, and Zman Jusaman means on the same side, it is same as cis. When I will give you one example, then you can understand. First condition, you see that carbon and carbon has at carbon and carbon, this carbon double bond, two carbon along two carbon along two sides of the double bond has attached with the four different group of atoms: bromine, iodine, methyl, and H. So here our first condition is now satisfied, that if the four group or atom attached with the carbon double bond carbon, then we can't designate it by cis and trans. Now we'll arrange it either this form or we can arrange this two form. Just I am writing why. I am telling you why. This is 1, this is 2, this is 1, and this is 2. That is, I am explaining it. That is 1 1 and 2 2. That is same type of groups are in same side. That is Z. And here this is now you see I have arranged, I am giving numbering. The reason I will show you. This is 1, this is 2, this is 1, this is 2, means 2 of the same type are in the same position, and 1 are the same position, it is Z. 1 same priority are of same side, 2 are same priority below, and 1 same priority above. And when I have just changed, I have kept intact of this one, and I have changed these two only, rotated these two. So 2 has gone above, 1 has gone below. So now what's happened? This is 1 and 2 as are there, it remains the same, and now it has become 2 and 1. Now we have seen across, that is lack of trans. So like trans, it is called E. So now how I have got this arrangement? 1 and 2. 1 and 2 are on the basis of priority order. Khan and Prelog has given this. Sometimes in entrance exam it is asked who has proposed this configuration E and Z notation. It is Khan and Prelog. They have given this concept E and Z. This is on the basis of priority. How does priority of the atoms or group can be ascertained? It is on the basis of the atomic number. More the atomic number, more will be priority attached with it. So iodine is more atomic number, then second atomic number is bromine. So I have given it 1 and 2 of this carbon. Now come over to this carbon. The first atom, that is carbon, not hydrogen, the attached with carbon is carbon. The carbon is atomic number 6 and hydrogen is 1. So in terms of atomic number, it has got higher atomic number than this. So it is 1 and it is 2. Am I right? So here also the same thing. So I have arranged, it is atomic number is more 1 and 2. Here atomic number of these two, carbon is more than hydrogen, 1 and 2. So this is 1 and 1 in the one side, and 2 and 2 are on the same side, same priority order are on the different on the same side, and it is Z. And when I have just changed by rotation of this carbon only, I have got 1 1 and 2 2. This is across, it is called E. Am I right? Now in terms of priority order, sometimes you will find some difficulties. Say if there is hydrogen and if there is deuterium, then the atomic number is same, priority order of this one will be more. And if you see, say all are carbon, one is CH3, other is COOH, other is CH2CH3. Say 3 groups, and all are carbon. All first one is carbon. Now how will ascertain the priority, which one is getting higher priority? Then you go to the next atom, next one, next is oxygen, next is, here in case of next is carbon, first one is CH3, next is carbon, here next is oxygen, carbon on next is oxygen, here next is hydrogen. So this has got highest priority order, and this is 2 because here first one is carbon, next one is hydrogen, here first one is carbon, next one is another carbon. So in terms of priority order, you will get this is second priority order and this is third priority order. In this way you will ascertain the priority order in terms of atomic number. More the atomic number, more will be its priority, and if the atoms are the same, go to the second one. And if it is double bonded compound, so double bonded bond is there, then you assume that single, C double bond O, single. If there is triple nitrogen, C triple bond N, so you assumed it in this way. So these are in short the simple way to find the priority attached in EZ notation. So this is all about geometrical isomerism, and next I will explain with optical isomerism, very important. And third one, conformation isomerism, only I have given in hydrocarbon part. I will not explain this one. I will explain just the last one is optical isomerism in my next class. This is the end of my today's lecture. Hope you have enjoyed the class, and I request you to subscribe the class in order to get a lot of new things upcoming uploading things I will going to upload for entrance, especially entrance point of view, and also you will get a lot of things in second year. Thanks a lot for watching the class.